All right. So September 10th, this is the last free webinar I'm running, the 8th one so far, and I really enjoyed it, and I hope you guys have too. It's a nice place, hopefully, that can give you something to look forward to as you're studying for the MCAT on your own, having something weekly to look forward to that has more than just yourself. You know, you have a group of people that are all kind of having the same goal. It definitely helps. So I really appreciate you guys coming in. So essentially the same thing. Any specific passages that you'd like to go over? I think I've already gotten requests for physical sciences and psych because we didn't really do many phys and psych. So we're going to jump into those first, and then we will we'll just play it by ear at the end. So wherever you guys are at, I just wanted to note a few things. The first thing is that keeping yourself accountable is really important. You know, when I first got into studying, I had set myself up with a structure that was basically 8 hours a day, 7 days a week. Remember, I quit my job at that time, so I didn't have any work or other priorities. So what happened was I gave myself 8 hours a day, 7 days a week for 10 weeks. So that's 56 times 10, 560 hours of work that I gave myself. Now, did I actually stick to it all the way and knock out 560 hours of work? No. I think from what I tracked, I was about 100 hours shorter. So that's a pretty sizable difference. So I can only imagine with those extra 100 hours of work what additional improvements I could have made. But it was definitely good enough. And what I would say to you guys is, if you aren't already tracking your time, or if you're finding yourself wondering why tracking your time is necessary, it's because, you know, we had this in a previous session where, you know, our perception of time is kind of variable. You know, some people might, if I told you to tell me when it's been a minute, you might stop the clock at like 50 seconds or maybe a minute and 17. So if you extrapolate that to 500 hours of studying, there could be tens, if not, you know, 10 to 20, 30 hours that we lose track of over the course of a few weeks or months. And so to be able to go back every single day and look at the report of what all you guys have done and accomplished, you'll be able to make data-based decisions, which is hugely important when you're managing either a business or a team or just yourself. And so one tool that I like to use that some of you guys are already familiar with is Toggle. So definitely give that a go. It's free, and it'll allow you to time how long it takes you to you know, go through this boogeyman method at each stage. And there shouldn't really be any difference in how much time you're spending practicing versus analyzing versus organizing or drilling. The point is that you should be progressing in how much you get done with the same amount of time. So basically that is time management. So the second thing is that when you guys are studying by yourself day in and day out, something that I found that really helped me was being able to keep myself organized. And so keeping a simple Google spreadsheet is also pretty helpful. You know, whenever it comes to you guys tracking the new concepts or terms or questions that you find from whenever you're analyzing a passage that you've done. So if you go to my website, there is a link in the resources. You just click on MCAT spreadsheet. It's just basically, this is the format, and I'm going to be improving it by next Sunday. There's going to be an update to it that's more detailed and has more instructions, but essentially the principle is the same. You note down the date that you've worked on this passage and what problems it's located in, and what questions you had from the passage that you took. So when we're going to jump into this passage right here, remember that us jumping into this passage and practicing is only the first step in the boogeyman method. It's only practice. But the real key indicator, and I shared this with you last time, a guy who got a 520 in the MCAT who recently reached out to me to tell me the reasons why, he said that the biggest thing that he did differently was that whenever he would practice anything, he would analyze the crap out of those passages. He pulled out every single question that he missed. He made sure that he understood in the form of questions, and he put those questions into flashcards. And even the questions that he got right, he knew that there was something about it that he could learn, so he extracted everything that was possible from every single passage, and that's analysis for you. Now, how you organize those things is up to you. For me, again, I like to put them in spreadsheets, and then from those spreadsheets make flashcards out of them, and then drill those flashcards. But the point is that practicing is one thing, but going over what you practice so that you can learn something is the only possible way of growing. So whether it's strategy or content. So really, really want to stress that a lot. Time management, keeping yourself organized because there's a ton of things that you'll have to study, and then analyzing the crap out of your passages. Really make sure that you're keeping yourself accountable for those three things. And if you need help keeping yourself accountable, again, I'll have a resource for you guys come next Sunday. So with that being said, let's dive in to this passage. Oh, Bianca's said something. She says, I feel like I never have time to go over what I practiced. Okay, so this is less a problem of, this is less of a nebulous problem that you may think. It really has to do with adherence to a structure that you've laid out for yourself. For example, one thing that I do when it comes to practicing is I will set myself 8 hours, period. Pencils up at 8 hours at the beginning, and then at the end of 8 hours, pencils down. So in 8 hours, how many passages can you get through? I don't care what sections it's from. That's up to you. If you feel like you want to do more bio that day, do more bio. If you feel like you're kind of lagging with cars, do some cars. Do all 4 sections like I do. But basically, give yourself a fixed amount of time. And then whenever that time is done, you are done practicing. You need to move on to analysis. You need to. The reason being, and again, the reason being is because it is so crucial to extract the moments when you were confused while practicing. Because it's so easy to tell yourself, or at least it was for me, it was so easy to tell myself, to trick myself into believing whenever I read the answer key, whenever I read the solutions, that, it'd be basically pretty straightforward. You read a solution, and then what happens is, again, you tell yourself that you could have gotten that, or you should have known that, or, oh, I already know that. So maybe, Bianca, in your mind, what might be the issue apart from time management and giving yourself a fixed amount of time, could be that you don't really understand the importance of analysis just yet. Because if that importance is there, it's a non-negotiable part of the studying process. It really, really, really is that important. So that's what I would say, Bianca. Set yourself up, maybe 6 to 8 hours, strict practice as much as you can, and then stop. And you have to move on. And the next step is the next step in the cycle, which is analyze. And then once you're done with analysis, and you've put everything that you need to into your study bucket, then you can go ahead and organize them into flashcards, drill those flashcards, and then another 6 to 8 hours of practice. Does that make sense? Hopefully it does. Got another question. Yes, okay, good job, Bianca. Okay, so Foreste says, right now I have some MCAT textbooks. Do you feel like we should learn all the info first, then start questions? Because I still have a lot of learning of the material to do. Thank you. That's a really good question, actually. So this is something that I had a conversation with this a couple webinars ago. There was only 1 or 2 people who jumped on that day. So what we had spoken about is that you are all on this MCAT study group right now. You're all here, which means that you all have some background in some of the content. You're not completely blind. Even if the last course you took was an AP high school course in biology, You're not going into this stuff blind. Therefore, the most efficient way that I've found to really understand, and let me ask you a question, Fareshte. If it's true that you have a ton of material that you need to learn, how are you going to be able to prioritize what to learn first? There's really no way. I mean, there is a list, if you go to my website and if you click on the blog, you can see in the blog that there's a list of high-yield topics. And this is true. But even then, the list of high-yield topics is more than a dozen. So again, how do you know what to prioritize? So it's about prioritization and time management, being able to know exactly what specific concepts that you need to study. And the best way that I've found to do this is the specific concepts that you didn't understand from the passages that you took. So, Fareshte, if you look in this passage that we're about to do together right now, and you just briefly, right, let's see, the first term right here that I see is gram-positive bacteria. Now, when you're reading this passage and you don't know what that is, as soon as you're finished practicing, you're going to analyze that, and that's going to go into your bucket. So you're going to come in here and you're going to add in, what does gram-positive bacteria mean? And you're going to keep on asking yourself questions after question after question, and you're going to find out that you can extract dozens of questions from a few passages. But those questions, as opposed to studying by yourself, are so focused, and you know exactly how they're applied in the sense of the MCAT. And now you're saying that, oh wow, that makes sense, I should do that, haha. That's good. I'm really glad that it makes sense. Try it, okay? It's just something that has worked for me and several of the students that I've worked with. It's worth a shot, and logically, you can think about to yourself that, yeah, if I was just given the instructions of, okay, go study content, as opposed to take this practice and then study whatever the practice was, you're going to find out that the time that you spend in the first situation is way less focused, very, very scatterbrained, and not as organized, because especially when you go through all that content, at the end of the day, you still have to be able to apply that knowledge to the practice passages anyways, so you might as well kill two birds with one stone. Learn the strategy as well as the content as you go from day one. So you're saying, so basically don't read the books cover to cover? Phew. Yeah, books are a resource to fill in the gaps of your understanding. If you're confused about a topic, turn to your books, open to the relevant page, read it, put it in your flashcard definitions, study it, move on. Personally speaking, I don't think that you need to spend any money on any books because the internet has all the information you need for free. But the MCAT test prep companies are going to tell you things otherwise. So it's completely up to you. If you already have the books, like I did, I think I had the set of EK books. I use them. So what? Okay. Even though online there are much more extensive resources as it pertains to the specific questions that you will have from the passages that you study. So definitely give it a shot and use your prep books as one resource. Your friends could be another resource. Google could be one resource. Khan Academy, AK Lectures, me. There's a lot of resources out there to help you understand concepts, because not one book is not going to give you the perfect descriptions and definitions for every concept in science. It's just not possible. We're all different. Okay. So if no other questions that are urgent, let's take a couple minutes here, and we're going to approach this physical science passage silently, and then we'll answer it. Hopefully you guys will be able to give me some good answers. Okay, so let me zoom in here. Yeah, there you go. All right. Now, remember that the strategy when it comes to the 3 science passages is to read the first paragraph, and that's it, then go straight to the first question. Okay? So you read the first paragraph, and then we're going to go straight to the first question. If we can answer it, then move to the second question. This will make our time very efficient because not every passage requires us to read the whole passage. And if there is even a few minutes that we can save, that's a few minutes that we can spend on a harder question later on in the test. If we cannot answer the first question, we have to understand what this problem is asking of us. Make sure that we have in our heads the list of a few questions that we can extract from the first problem, and then we use those questions to guide us into the next paragraph, and the next paragraph, and the next paragraph. So it's a very efficient way of reading. It's something in psychology called priming. You prime yourself to look out for the relevant pieces of information. Okay, so let's jump into it. And even though for those of you who already know these strategies and concepts and approaches, you might be able to know them. Walter says it's probably coincidental that the passage questions are in sequence like that. I would agree. And I'm not going to say 100% that's what happens, but I will say that it happens enough times for this strategy to be warranted, for there to be a lot of time that could be potentially saved. So there's no harm, no foul. With cars, I do not do this. With cars, I definitely like to read the whole passage. If I'm pressed for time, then I read the passage up until I understand the main argument, and then I go to the questions. But for the three scientific passages, going one paragraph at a time, one paragraph then to one question is something that I like to do. So what was I going to say? Yeah. So for those of you that you already know the approach, you might be able to know it in your head, and maybe me repeating it might seem like a waste of time. But I promise you, think about the things in your life that you know based on theory, but you have failed to put it into practice yet. I mean, it could be any habit in your life, but that's the point. Habits, they take time to build. So hopefully none of you guys are taking the test tomorrow, but it's okay to kind of have this repetition because that will only help solidify really solid and perfect strategy and perfect habits so that you won't have to worry about something going wrong on the test day. You want these things to be subconscious. Okay. We have another couple questions here. Sorry, but do you recommend taking notes / highlighting on the science passages? Do I recommend? So the way that I can answer that question is using this principle. If it helps you understand the passage, do it. But if you can handle the passage's content completely in your head, don't. Why? Because if you can handle it all in your head, it's a waste of time to write it on paper. Nobody's grading the paper. No one's going to be checking the paper at the end. The point of the scratch paper is to relieve some stress from your brain in trying to grasp and handle all these different concepts simultaneously. That's the only use of the scratch paper. It's basically a brain dump. You take what's in your head and you dump it on the paper. But as you study and as you practice, your ability to hold several pieces of information simultaneously will improve. For example, with cars, I used to take notes after every single paragraph. Now, I can do it all in my head. But guys, I've been doing that for years. So at the start, I took as much as I needed to because based upon principle, it wasn't about taking notes or not. That's very superficial. It was about, is this going to help me understand the passage or not? That's the goal. So if you can do that while writing on paper, great. But if you can do that while holding in these information in your head, even better. Okay. One thing, though, as it pertains to science passages, which was your initial question, is that flowcharts are really helpful. For example, you're going to get a lot of passages that have flow diagrams. Maybe you know, this enzyme triggers this thing, which catalyzes this thing, and that leads to this, which leads to that. That is almost always too confusing for my brain to handle all at once. So I like to draw a picture on the side. When it comes to highlighting, I highlight almost nothing in scientific passages. I completely have my pen and my piece of paper. So what I would recommend, this is the last point, is that on science passages, whenever I'm reading the passages in general, I have the pen in my hand, or the pencil, whatever you're given in the MCAT, I think it's a pencil. So I have my writing utensil in my hand, and I'm tracing my finger along the passage line by line. And I'm reading it slowly at first, especially when I'm first starting out. I'm reading it slowly, and then my speed improves over time as I train, weeks after weeks after weeks. But my pen is always in my hand because the moment when I start to get confused and my brain's like, okay, I can't handle this much information, my pen is already here, boom, write it down, and then right back to it. So that's usually what I do. I like to say that I read like a third grader because I still trace with my fingers, but it helps. And again, nobody's watching you, nobody's judging you on how you read. It's always about, does it help you understand the passage? If so, do it. So, hope that answers your question. All right, let's get into this passage. The first thing that I like to do when it comes to scientific passages is I like to read the title. So this one says adapted from Way. The title is isothermal titration calorimetry. Those are three really big words and I'm already confused. So one second. Break it down. If you know what this means, isothermal, isolated temperature, I suppose. Titration, okay. We know what that looks like. Calorimetry, hopefully we know what that looks like. Again, it's the metric, the measurement of calor or heat. And macromolecular visualization for the interaction of lysozyme and its inhibitors. Lysozyme meaning an enzyme, and enzyme has inhibitors. So we got some things to do with calorimetry, measuring heat, titration, and then enzyme kinetics. So really it should be an interesting passage. Now, what I do is I scroll up to the top and I close my eyes every single passage. It takes me about 2 to 3 seconds to do this, but it allows my stamina a lot of help. It gives my stamina a lot of help, so I'm able to go passage by passage. So what I do is I read the title, and then I come up to the top and I close my eyes and I take a deep breath. And in my mind, while I'm taking that deep breath, I'm pretending that there's a file cabinet in my brain, and I'm pulling out the topics that are related only to this passage. And the topics are, again, enzymes, calorimetry, titration, and inhibitors. And so I'm pulling out those files, and I'm focusing on only those files, because what that does is that, sure, you might not need to do this for the first passage like what we're doing right now, but imagine that it's been an hour and 20 minutes, you've done 6 passages and several discrete questions by now, and your brain is still thinking about passage number 3, which you forgot this and this answer, and then you have to go back to because you marked the question. So in order to give your mind a break and to focus on one passage at a time, read the title if it's given, come up to the top. If it's not given, you can quickly peruse the passage and see what it's about. You can see molar ratio, you can see a titration curve, you can see K values, you can see enzymes and amino acids, so you have an idea of what it's going to include. So you do that, and then you close your eyes, take a deep breath, 2-3 seconds, focus on that topic, and that will completely rid yourself of the anxiety, well, temporarily at least, rid yourself of the anxiety of the previous passages, and also the anxiety that comes with the future passages that are coming in. So do that, and then whenever you finish doing that, go ahead and jump into it. So guys, please read this first paragraph, and I'll give you about 30 seconds or so, maybe a minute, and then we'll scroll down to the first question. Good luck. Oh, sorry, I guess my phone got disconnected, but okay. So you guys should definitely be done with that paragraph. Apologize for that. Okay, so let's scroll down and we will see if we can answer the first question. So according to the passage, okay, and whenever it says according to the passage, that's basically the AAMC's way of telling you, hey, the answer to the question is literally somewhere in the passage. Go find it. So what type of bond is cleaved by lysozyme? Can anybody tell me? First of all, if we can answer this question based upon that first paragraph. If so, what's the answer? So we got peptide, phosphate ester, glycoside, pyrophosphate. And the first paragraph is here. Walter says peptide. It is an N-acetylglucosamine oligosaccharide. Okay. Sandra says, is it glycoside? So everybody's saying peptide, but Sandra is saying glycoside. Sandra, why are you saying glycoside as opposed to peptide? Oligosaccharide. Do you want to be a bit more specific? Because, yeah, they're sugars. Yeah, that's right. So I don't know if you're typing still, but basically, yeah, Sandra is right. It would be a glycosidic bond. So very good, very good. If that is confusing, then again, what's going to happen is that once we're done with this passage, we're going to come into the spreadsheet, and you guys are going to kind of put down whatever questions you didn't know. For example, what is a glycosidic bond versus peptide bond, et cetera, et cetera, et cetera, and you learn from there. But yeah, Sandra, great job. It's a glycoside. That's correct. So really quickly, I want to make a note that when you guys are problem solving, this is a really good concept. I'm not sure how many of you guys learned. Walter says, I think I saw amino acids, so I was tipped in that direction. Okay, and this is actually okay. That's a really, really good lesson to learn, and that's, Bianca says, me too. She was tripped up by amino acids. So, yeah, the molecule itself is a sugar. And so this is the way that you're going to avoid ever getting tripped up again, okay? So I'm not sure how many people learned or took a course on problem solving in college, but I remember my parents led me to believe that I was supposed to learn how to problem solve when I went to school. I didn't. Maybe they meant it kind of metaphorically, like you'll have to learn how to problem solve on your own or whatever. But in my mind, I thought that somebody was going to teach me how problem solving works. They didn't, but I'm going to give you guys a quick lesson on what I found helps me when it comes to problem solving. So the MCAT gives you problems mostly, not questions. They give you problems. So what is a problem? Well, for example, a problem is something that your brain cannot really handle with an immediate concrete answer. You don't really have an answer to a problem. You have a solution to a problem. And a solution is a set of answers. And so let me explain that a bit further. Imagine that I called you up, Bianca and Walter. I call you guys up and I'm like, guys, I have a problem. Help me, please. Would you be able to help me? No. Why? Because it's not enough for me to tell you I have a problem or for me to even give you my problem. It's that your brain is confused at problems. Walter and Bianca, you guys need to ask me questions like, okay, Nicholas, what's going on? Are you alone? Do you have anybody with you? Is there Is it a fire? Is it this? You have to ask a bunch of questions, and only after getting answers to those questions will you be able to take that information, take those answers, wrap them up into a solution, and then solve the initial problem. So it's like a tree, you know, problem is at the top, and then what you do is you take that problem and you break it down into their set questions like this, and then because they're questions that you've asked yourself, your brain is now able to say, oh yeah, well this is the answer to that question, this is the answer to that question, and this is the answer to that question. And the solution to the problem comes from any combination of these answers. Okay, there's a smiley face. Kind of looks a little evil. That's weird. 1 second. There you go. Okay, there's a smiley face. Oh, there you go. So, I don't know what's going on with that eye. So yeah, the set of answers is what makes up the solution. So, as it relates to the MCAT, let's take a look at this problem right here. So the way that you find out what questions to ask is by reading slowly. Again, remember, you have the pen in hand and you're reading on the screen, and you're reading slowly the problem up until the point where your brain starts to go, I'm kind of confused. And then you take that confusion, and instead of making it a statement which says, I'm confused, or I don't know what a lysozyme is, you say, instead of I don't know what the lysozyme is, you just turn that into a question. And very simply ask yourself, what lysozyme is it referring to? Right? Makes sense. So when you have that question, your brain now has some direction that it can use to be able to break down this problem and focus itself on only the relevant bits of information, and then put that information right here in the form of these answers. And then from there, you'll take this and you will be able to, you'll be armed with a set of answers that will be in the answer choice. Like, it will be there. It will lead you to the answer every time. So, okay, that's problem solving 101. Please make sure that that concept, let it marinate in your head, and think about every problem in your life, whether it's relationships or, you know, just like physiological needs, things like that. Any problem can be broken down in this way. It can be discretized in the manner of asking questions whenever you're confused about something, and then finding those answers to those questions, taking those answers, and then combining it into a set of solutions. Now, there could be a bunch, like an infinite amount of solutions, like possible combinations, but, you know, problem solving can't be all that easy. So, you know, you use different strategies to make sure that you pick out the highest probable solution. So that we'll talk about later. But this one says, according to the passage, you know, when I'm reading it, according to the passage, I'm not confused yet. It says, what type of bond is cleaved? Now I'm confused. I forgot what bond they're talking about, what cleavage, what lysozyme. So essentially, the first question that I could probably ask myself is, what cleavage is occurring? And then you go up to the passage and maybe you see, let's see, an enzyme that, it says that lysozyme, blah, blah, blah. So right here you have cleaving this. So you found that answer. You know what's being cleaved. Great. So that's your first answer. You know that the oligosaccharide is being cleaved. Awesome. Now, it says by lysozyme. What lysozyme is it referring to? What's the lysozyme? And then you come to the top, and it's the same thing. Lysozyme is an enzyme that kills blah, 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 by that. And it's talking about this guy, specifically right here. But it actually didn't even mention HEW. It's just mentioning a lysozyme in general. So essentially, if you want to know what a lysozyme is, you can come here. So now you know what the lysozyme is and what it's cleaving. So if you arm yourself with that kind of a strict, disciplined manner of problem solving, you cannot fail. And if you fail, you will have specific and concrete questions that you can go back to and say, I need to find out the answer to that question because that is the gap in my knowledge. That is the missing link. Once I plug it, I know the answer. So, guys, you need to discipline yourselves when it comes to really building these good habits and realize that this is what's happening in your brain whenever you problem solve, or at least that's my opinion. I don't know. I didn't research this or anything like that. I just kind of, it's something that made sense to me, so I explain it to other people as well. But yeah, so now we know what bond it is, what bond's being cleaved, and we know what the lysozyme is. We know that it's this is the bond that it's referring to. Yeah, Walter says it makes sense to him. So the third question, I suppose, that really fits in the puzzle is, you know, what bond is being cleaved when you cleave a sugar, you know, out of the list over here. And the list includes the glycoside bond, so that would lead you to that answer. Okay, great. So let's move on to the second question. And I can already tell you that you won't be able to answer it based upon the first paragraph alone. So let's just kind of jump in and see, what is it asking? What is the approximate value of delta S for binding of NAG3 to HEW at 27 degrees Celsius? So again, at what point did you get confused? Well, I don't know what it's referring to with this. I don't really know what the binding of NAG to HEW means. And I don't know what any values of that delta S could be at 27 degrees Celsius yet. So I kind of have an idea of what I'm looking for, what are the relevant bits of information that I'm looking for. And now that I have that information in my head, I'm going to come up to the second paragraph and see if I can answer the question again, which is, what is the delta S for the binding of NAG3 to HEW at 27 degrees Celsius? So please, guys, go ahead and read the next paragraph. And if you feel like you have enough information to answer the question, please do. Otherwise, keep reading. But I think that you should have enough information after this paragraph. All right. Hopefully that was enough time. Are we able to determine? Oh, you know what's funny? You can actually have answered it with the first paragraph. You're right, Sandra. It doesn't help us, which is great. Apologize for that. I'm glad you caught that. Basically, we could have answered even the second question with just the first paragraph as well. So yeah, Sandra says, LOL, I kept reading and reading. Ha. Yeah, sorry about that, guys. Well, it's okay. Get practice. Live and learn. Okay, so we know, what do we know? We're trying to find delta S. So my first question is, how the heck do you find delta S when you know delta H and delta G How were you able to find that out? Delta S is change in entropy, so Gibbs free energy equation. I agree. I think that makes sense. Now, they give us a temperature, okay? Because remember, it's isothermal, so they give us a temperature. So now, can somebody please calculate and give me the answer so I don't have to? I'll write down the values of K. Negative 50 kg and negative 30 kg. Negative 50 and negative 30. I think that's right. Negative 15, negative 30. Yeah. All right. So you guys can use a pen and paper and try to get the answer and plop in the answer into the chat box. Walter says B as in balloon. Anybody else? Bianca? Anybody? Kyle? What do you guys think? Kyle says, is it A? Sandra is now stumped. Okay. Walter, do you care to help out the rest of the class? You got the answer right. You want to lead them down the right path? So Walter meant to write negative 30, which is G, plus 50, because he's adding it, divided by 300 Kelvin. And then he converted it into joules because it's in kg. Yep. That's correct. Good job. So now if you really wanted to be Gold Star students, you would tell me what it means to have a negative delta H, negative delta G, and a negative delta S. All right. So exothermic and exergonic, very good. Now, if you really want to be a platinum star student, not even a gold star, you would tell me what exothermic and exergonic means. But you guys get the point, Released energy. Very good. Very good. So Fereshte says, wait, why isn't it 20 divided by negative 300? All right, so let me get rid of this. And Bianca had 40 over negative 300. Okay, guys, so this might simply be just a mathematical error. So please try to go over it again. I'll try and do this one time with you. But whenever you're by yourself and you inevitably miss a question, it would be prudent to go step by step and really find out using a calculator where you went right or wrong. So, you know, you have negative 30,000 joules, right, equals negative 50,000 joules. And then you have, what is it? Plus 300, what's the thing? S. Yeah. And so when you have negative 30,000 and you have to add 50,000 to negative 30,000, you end up with 20K. 20,000, basically. Yeah. And I don't think I need to explain the rest. But basically, it's just a minor careless mistake that I think stems from a deeply rooted problem of trying to rush yourself. Perhaps, maybe, I mean, hopefully you don't, because we want to make sure you all feel comfortable. Yeah, you can convert to joules, but even if you didn't, Fereshte, I didn't convert to joules in my head when I was doing this problem. But because Walter was expressing his answers in joules and everything, I figured I'd just do it for consistency. But again, it's more a problem of going at your own pace. So perhaps you could have gotten the right answer if you would have given yourself 20 more seconds to check. You know? And when you do this enough times, you'll get faster and faster. But perhaps what might have happened is that because other people were giving their answers, you were like, whoa, I don't have the answer just yet. Walter already gave his answer. Bianca already gave her answer. I got to give my answer. Maybe I should stop. And so, Sandra, because you have to divide it by, she says, why isn't the answer, no, it's not A. The answer is B. Yeah. Yeah, it's not A. Yeah, no worries. So basically, yeah, Fereshte, just take your time. There's no pressure to rush. This is at your own pace. But just keep in mind that perhaps you're making these errors because of something less about how much you know and more about how much time you're giving yourself to apply what you know properly. Okay. Let's keep going. So basically, we've only read the first paragraph, and we've been able to answer the first two questions, which is fantastic. So let's try to answer the third question. And yeah, if you guys can answer it, please do so. If you can't answer it, then tell me and I'll go up to the top. So guys, basically, this, one second, let me mute people. Okay, so basically we're looking for the amino acids that can hydrogen bond, or that the one that cannot. So so the first question is, what is a hydrogen bond? What makes something able to bond with, in a hydrogen bond? And then which of the amino acids are there? We have these are the amino acids, and then it's asking us which of those amino acids is unable to hydrogen bond. So the choices that are given are 62, 101, 103, and 107. So out of this one, this one, this one, and this one, which amino acid cannot hydrogen bond, I believe is what it says. Yeah. 62, Sandra says. "62" says Sandra. Walter says 107. Bianca, Freshte, Pyle. What do you guys think? Don't have them memorized. Okay. No issues. No worries, Freshte. Bianca says W cannot be hydrogen bond. So you guys are all saying that tryptophan cannot have a hydrogen bond, and Walter, you're saying that alanine cannot have a hydrogen bond. So tryptophan versus alanine. Walter, can you explain why you got the answer correct? So basically, hydrogen bond is with one of those three. Yeah. Yeah. So that is basically correct. Yeah. Alanine, guys. Alanine is something that you need to know the structure for. Faresha, you said you haven't memorized the amino acids yet. Basically, there are 20 amino acids. 19 of the 20 have alanine as a backbone, including alanine itself. So the alanine backbone, the way you draw it, and this is the beginning of every single amino acid except for glycine, and glycine only has an H as the R group over here. So what you do is you have this, okay. Definitely memorize those guys. So this over here, whenever you draw this stick by itself and nothing else, it's assumed that there's a carbon here. But essentially, for posterity's sake, we'll just put this thing here. So this is alanine. This guy is alanine. And the R group is what we're looking at. So this is going to be what every amino acid has, but what we're trying to do, the relevant part of the side chain has to do with the R group that's attached to the N and C terminal. So if it's a carbon over here, remember that Walter said that you need either a fluorine, a nitrogen, or an oxygen in order to properly have a hydrogen bond with the side chain. So this one has only a carbon, and as a result, it won't be able to develop a nice hydrogen bond. So what I would recommend is there is a video series that will allow you to memorize the amino acids pretty easily. And you can just look it up on YouTube. It's called Draw It Know. So look up this on YouTube right here, Draw It Know amino acids. And then there's like a, I can't remember, I always forget what it is. So it's like amino acid quiz. Sporkle, yeah, it's on Sporkle. Sporkle, this guy. So this guy right here, Sporkle, amino acid, picture quiz. Oh, not Sporkle. So basically, by watching that video, by doing that game, and then literally setting aside 15 minutes per night to write as many AAs from memory as possible onto a notebook. So you're just going to have a notebook and you're going to fill out paper after paper after paper with the 20 structures, 3-letter codes, and 1-letter code, as well as the name of all 20 every night after about, I would say, maybe 2-3 weeks max. With the video, the quiz game, and the notebook, you will have them memorized by heart. Which is important because the amino acids in biochemistry is arguably the most tested subject on the AAMC, most consistently tested. I mean, guys, this is not even a biological science passage. This is from physical sciences. So you can imagine it's prevalent. Yeah, great. So it's D. What quantity of NAG3 was required to reach the equivalence point in the titration? What titration? What equivalence point? Okay, so we don't know yet. We have to read the second paragraph. So we're looking for the quantity of NAG3 required to reach the equivalence point in the titration. NAG3 equivalence point titration. Okay, so if you guys have already read this right here, basically looking for the quantity of NAG3, which is the graph on the left. We're looking for the equivalence point, which is the point that it has an inflection, which happens right at 1, so a 1 molar ratio. So now the question becomes, what does it mean to have a 1 molar ratio? Okay, and then you go from there. So let me know when you guys figure it out. But again, the question is asking what quantity of NAG3 was required to reach the equivalence point in the titration. And I've given you a head start because I know that I made you read this paragraph prematurely, so please do your best. Anybody have an answer? Can you scroll down? No worries. Sandra says, I'm sorry, I can't type. Not an issue. So it's okay not to know if it's A, B, C, or D, but the the question, how much NAG 3 was required to release equivalence point? So again, guys, what does it mean to have an equivalence point? What does it mean to have a molar ratio of 1 to 1? It's a molar ratio of NAG 3 to what else? These are the questions that you can begin to ask yourself in order to figure out what the problem's really requiring. So once you systematically ask the right questions, get the right answers, you'll be able to put that together in a nice solution and get the right answer. So yeah, anybody have any ideas where they're at? So yeah, 1 to 1 of NAG 3 to HEW. That's great. So we know we have 1M to 1M ratio. Well, how much it says to reach the equivalence point, what quantity of NAG 3 was required. So it's asking about how many moles. So we just basically, if it's 1 to 1, we know that how many ever moles of HEW alone there was, there'll be the same amount of moles for NAG 3, okay? And that's it. So we find HEW's moles by looking over here. We can use the molarity equation, which is molar equals moles per liter of solution. So we put 0.1 millimolar over here, and it's 10 to the negative 4th molar equals 1 milliliter. So x moles over how many liters? So it's 1 milliliter. So that is equal to 10 to the negative 3rd. This times this is 10 to the negative 7th. So I'm guessing that it's going to be 10 to the negative 7th mole. Anybody else agree? Ten to the 7th mole. The negative 7th mole. Bianca agrees. 10 to the negative 7th mole. So that's how many moles. So B, let me see. The 1 to 1 molar ratio actually what I think we need to do is, because it's a molar ratio, this is the same. So this is molar. but the quantity of NAG3 is under question. So we have to take the molar ratio at the equivalence point. So we take this here, and perhaps multiply that by that, microliters. Is that true? No. Yeah, I think it's 10 to the negative 7th, what I thought. Yeah, 10 to the negative 7th. So what is that, B? Yeah, 10 to the negative 7th. Yeah, so nanomolar is 10 to the negative 9th, and so 100 times 10 to the negative 9th would be 1 times 10 to the negative 7th. Yeah, so B. I feel like I got very quiet. So just out of curiosity, a molar ratio of 2 would mean 2 to 1 of NAG to HEW. First of all, it's NAG3, and it's an important distinction because there actually is a plain NAG up there as well, but it's just talking about NAG3. But yes, you're right, Pyle. It would mean the molar ratio of NAG3 to HEW would be 2 to 1. Correct. So Bianca's saying at first I was just looking at the graph. Okay. So yeah, I was just saying that I got kind of quiet. Is the calculation upsetting? Is it confusing? How I got to that answer? Any questions, guys? Because remember, this is not for me. This is for you all to understand. So it's okay if we take more time on this. Pyle says it makes sense to her now. Very good. Okay. Bianca says, yes, I wouldn't have thought to use that equation. Fereshte says, I just really do not understand why we didn't use NAG3. So I get it's 1 to 1. Okay. I don't get the molar ratio thing. All right, so we got some questions. Okay, after seeing you do it makes sense now. At first, I just struggle with the approach. Okay, guys, so let's break this down. Let's see if we can kind of make some progress here. So the question again is asking, what's the problem? The problem is quantity of NAG3. First question is, what does it mean quantity? It means moles. Great, so we're looking for moles of NAG3. Number 2, equivalence point. What is it? Anybody can anybody define for me what equivalence point means? But basically, yeah, Walter, you're right. Exactly. It's where the moles are equal in solution. The moles of X equal to the moles of Y. Okay? So that is a key point. The moles of X are equal to moles of Y at the equivalence point. Okay? Great. And in the titration, well, there are 2 titration curves. So what is the titration that it's referring to? It's referring to the one that has NAG3 and not the one that has NAG. So we go up there and we have our questions. We're kind of fumbling around with what we're looking for. So it says, the figure 1, it says that these are the graphs. So we have the one with NAG3 and HEW alone is on the left. So we know not to use this. Okay? So that's one. Now we read the paragraph and it says, unlike NAG3, the monomer interacts weakly with the HEW lysozyme. and it's not possible to measure K-nag or delta H of its interaction directly. Researchers use CITC to measure the heat of interaction of nag with HEW lysozyme. HEW lysozyme, which has this, was titrated with 25 injections of NAG3 in the presence of various amounts of nag. And the heat associated with each injection was measured. Modeling of the blah, blah, blah gives apparent, okay. So a couple things, guys. So number one, we are not using this, okay? We are using this. And what does that graph have to do with the values up here? Well, the values of NAG3 that they gave, which graph did those values of NAG3 refer to? 1, 2, or both? And if you can answer this question, that will clear up the problem for you. Exactly. Bianca's right. The values for NAG3 that they gave you only refer to the second graph. And we've already established that we're not using the second graph. Why? Because we don't want to know about nag. We only want to know about NAG3. That's why they give us this first graph, so that we can figure out the amount of moles required with NAG3 and HEW alone in order to reach the equivalence point. So that's the first question that hopefully that clears up for you, Farishte. That because the question asks us what quantity of NAG3 was required, and then it says in the titration, well, there's two titrations, so if it says the, that must mean it's one of them. So which one will give us just the quantity of NAG3? It's the one where it only has NAG3 in it, and that's the first one. So that is the reason why we cannot use these values. Okay? So what do? Well, luckily, they ask us about the equivalence point. And we know that the equivalence point is when moles equal moles. Okay? Moles of X equals moles of Y. And we know that the equivalence point happens at the inflection point of a titration curve. So that's why I traced my line down here to a 1 molar ratio, which is great. So this 1 molar ratio means that at this equivalence point, there is a 1-to-1 molar ratio, meaning the ratio of NAG3 molars to ratio of to HEW molar is 1. Okay, so that is a blessing, and that's the only reason why we're able to solve the problem. So now let me ask you this final question. You should be thinking to yourself now, well, is this right here, is this for only graph 1, 2, or both? These values right here for HEW lysozyme. They are for both. You got it, Sandra. Exactly. So because the HEW lysozyme is the constant in these situations, we can then, Farishte, we can then use these values plus our understanding that it's a 1-to-1 molar ratio to safely assume that whatever amount of moles we get for this is the amount of moles that we'd get for a NAG3 at the equivalence point. Okay? Walter? Sandra's asking if it's 2 molar ration, which is in numerator and which is in denominator. Okay, let's try to understand this. So I don't now that you're, I think somebody asked me that in the past, and I think that now that I'm reading it again, I I don't want to tell you that I'll be able to know. I got to be honest. There's no way for me to tell. Anybody else know which one would be? And I mistakenly answered the first question when I shouldn't have. Yeah. So if it was over here, we'd be out of luck. But then again, the AAMC would not have asked us that question because they give us the information that we need in order to solve the problem. So yeah, feel blessed. It won't happen. Don't worry. If they were to ask a question that had a 2 molar ratio, they would have made it clear. Trust me. Okay? Trust me. Walter says, so is graph 2 supposed to be the same titration, just with 20 millimolar added to the titrant? Yeah, it's with the same lysozyme. It's a titration with the same lysozyme. Yeah. Or analyte, I think, yeah. Yeah, the titrant is something that is added to the solution or the solvent or whatever. The analyte could be anything. The analyte is whatever it is that you're trying to analyze for. Okay, guys, awesome. So that was a doozy. But we got through it, and hopefully now you're armed with some data interpretation skills that perhaps you might not have been able to get in your books. But yeah, that's basically it. Any other questions on this guy? Again, all of these passages are from the AAMC section bank, so you will find them there. Unless they've changed it. Because I think the last, when I copied these guys, it was back in March of this year. So it's been a while. But, okay. What was the experimentally determined value of K-nag from the study described in the passage? Okay, again, guys, it says in the passage, which means it's in the passage. Where in the passage? From the study. Which study? I have no idea. So let's go up and try and find out. Walter says, by the way, I think the 2 molar ratio would have NAG3 added on top. That's what I think as well. But, I mean, if I were to ask you, Walter, what proof do you have? I mean, there would be none. Apart from just grammar. You know what I mean? It just says, like, grammatically speaking, NAG is first. But I must be missing a concept, is most likely what it is. But in my opinion, again, it would be clear. Yeah, Walter says it's probably conjecture. Yeah. Anyways, let's move on. So the question, again, guys, it's asking us to determine what is the experimentally determined value of K-nag. So we're looking for K-nag. First of all, what is K-nag? Second question. And what am I doing right now? Again, I'm making the thing in my brain, this tree diagram. I'm pulling out the points along this problem that confuse me, and I'm turning those points of confusion into a question, and systematically going into the passage and finding those answers. Okay, so what is K-nag? What study is it referring to? Okay, let's go see. And how do you find K-nag, the value? So what is K-nag? Okay, let's see. So K apparent is mathematically related to the affinity constant of nag. K-nag, so here we go. So K-nag, we found the first answer to the first question. What is K-nag? It is the affinity constant of nag. So check. And it's related. So that's our third question was the second question was what's the study? The study is the same thing up here, I suppose. And so the third and final question was how do we find out what the value of K-nag is? We use this equation. All right. So we have over here this equation. Now it's K-nag 3 over K apparent equals 1 plus K-nag times the concentration of nag. Can anybody tell me which equation from algebra this is? Come on, give it to me. It's an equation of a line, I can tell you that much. Here we go. You guys got 5 seconds to tell me the general equation of a line from algebra. It's okay if you don't know it, but hey, Walter, y equals mx plus b. Bianca, you got it right. Great job. Okay. Yes, this is y equals mx plus b. Fantastic. So the slope, guys, we're looking, remember, out of our 3 questions, we were looking, the last question was, how do you find the value of k nag? Well, you now are given an equation, and that equation tells you that it's the slope of this line. So please, somebody give me the slope of that line. And then once you determine the slope of that line, that's the answer. So remember, we had 3 questions. We answered the first one, which was, what study is it referring to? We answered the second one, which is, what is k nag? Now we answered the third one, which is, how do you find the value of k nag? So we've done this, this, and this. Put them all together, and you get yourself a solution. So please, somebody tell me, what is the value of the slope? There. I will forbid you from scrolling down, because once you find the value of the slope, you'll be able to get the right answer. Sandra says 0.8 or 1.2. I forget which goes on top and which goes on the bottom. Rise over run. Delta y over delta x. Rise over run. And Sandra says, I thought so. Good. Walter, we cannot scroll down. I'm sorry. You just have to find out the answer to the slope. What is the slope? And once you find out the slope, whoever gets the slope right first, Walter says, I think it's 40. 0.8, I believe, if I did it correctly. Pyle says 67. Okay. So we got 3 different people, 3 different answers. Bianca, Farishte. What do you guys, it's okay. Farishte says, I got 42. Basically 40, okay. Bianca, I think we want to hear from you as well. So y'all getting 40. Okay, let me see if I can do this as well. Well, let's see. So you have rise over run. So I'm gonna pick an easy one for my brain. So I'm gonna pick 2 and then 1. So 2 minus 1 is 1, and that's the rise. So 1 goes on top. Bianca says, JK, I got 50. Okay, so the rise is 1, and then what's the run? So we have 0, and we're going to go to 0.02. Okay, so 0 minus 0.02, or sorry, 0.02 minus 0, so we have 0.02. So what's 1 divided by 0.02? What's 1 divided by 0.02? 0.02 1 divided by 0.02. Well, the way that I have it in my head is 1 over 1 over, what's 0.02 in a fraction? It's 5 over 100, I believe. Right? So it's 1 over 1 divided by 5 over 100. So 1 over 1, we're going to cross multiply it by the reciprocal. What am I saying? Not 5 over 100, it's 2 over 100. So 0.02 is 2 over 100, so we do that. 1 over 1 times 100 over 2, so the answer is 50. So Bianca wins the cookie. Bianca wins the cookie. Good job, Bianca. Wahoo, she says. All right. Very good. Except cookies are kind of unhealthy, so I will give you an apple instead. Very good. Okay. Guys, did you follow me? What were some of the things that you can learn from when approaching these problems? Notice how I picked the easiest possible numbers to work with. I picked 2 and 1. Fresh Taste says to work on a larger scale. Exactly. But it's not necessarily the larger scale, it's the principle. The principle behind what I did was, again, pick the easiest numbers to work with. Why? You're trying to manage your time on the MCAT. You're trying to take the stress off of your brain. You're trying to do all these things by paper and in your mind. So whatever makes it easier for you, nobody is grading your method. They're just grading your score. So do the cheat codes, okay? Use the easy numbers. 2 minus 1 is 1. And then we go over here. So when you use those y values, you have to use the corresponding x values. Remember that. So it's 0 and 0.02. So we had 1 over 0.02. And the way I did it in my head was I turned this into a fraction and this into a fraction. So it was 1 over 1. And then you have to multiply it by the reciprocal. And so 0.02 is 2 over 100. So you flip it. Again, 100 over 2. This becomes 50 times 1 is 50. So definitely much simpler. And don't let yourself fall into this psychological trap where you tell yourself that because it's the MCAT, that somehow it has to be super hard. No, they know that that's how you think. And so they're hoping you think that way and make these silly mistakes. So don't fall into this trap. It really isn't supposed to be that difficult. Especially because they know there's no calculators involved, and pre-med students don't really need to take that much in terms of math, so they keep it simple. I mean, you guys remember y equals mx plus b. So even though this looks crazy, remember to find the patterns, you'll be much better off. Okay, last question, finally. A similar type of experiment is also conducted by injecting compound 1 into a solution of protein A, giving large measured heats and a high affinity constant K1. Another experiment is given under identical conditions, but in the presence of compound 2, and gives the same heat curve and a K apparent equal to K1. What change to the experimental conditions can result in measurable heat differences and a K apparent that's less than K1? So guys, this is basically the entire passage, right? Compound 1 is NAG3. Compound 2 is NAG. It's basically the same thing. Protein A is HEW lysozyme. So they're basically just repeating themselves. So basically all you have to find out is in the experiment above, in the passage above, what happened with the levels of the concentrations of NAG and NAG3? What did you need to do in order to reduce the K apparent? Did you need to add more NAG? Did you need to add more NAG3? Decrease NAG3? Decrease NAG? What resulted in reducing the K apparent? which means reducing the affinity. Having more concentration of what compound reduced the overall affinity? So NAG, right? NAG is the one that interacts weakly. And K is the affinity, right? Affinity is the measurement of how strongly or weakly some things interact. And so it's telling us that the K apparent, and if you know the K apparent is it's whatever we think that the affinity is going to be. They're saying that the K apparent equals K1 as opposed whenever you add in compound 2, and they're asking for how you can reduce the overall affinity, what you can do. So you can add in more of this compound 2. You can add in more of this compound 2 to weaken the interactions, just like you can add in more NAG to weaken the overall interactions with the HEW lysozyme. I hope that makes sense to you guys. That, again, it's my brain kind of found a pattern in this problem as completely relating itself to the passage as a whole. It's like a micro world, microcosm. This being, again, NAG3, this being HEW lysozyme, and this being NAG. It's the same experimental procedures. Even it says over here, identical conditions, right? That's the same thing as how we have these two graphs over here, and the identical conditions being these. So hopefully it makes sense how I equated those two things. So the question would be D, or the answer would be D. Yeah, Bianca, is it D? Yes, it's D. That's right. Okay. So that passage, that was one passage, guys, that we did. And we picked it apart and left no scraps behind. So, and I'm sure there's even still more that we can analyze from it. But does anybody have any overall questions about this problem? Because it was kind of silent while I was going over this problem. Any confusions? Anything I can explain for you? Let me unmute everybody. Walter says that passage was icky. Okay. Apart from this passage, any questions on the concepts? Let's kind of go over it real quickly based upon our strategy checklist. So you'll get an idea. So let's pretend that this is the only thing you got through in terms of practicing. Bianca says definitely a more challenging one. Okay, good. I'm happy. The more challenge we get, the more potential for growth we have. Okay, so Sandra says, if you did not know the equation of a line, how could you solve that question? you need some basic of math. For example, you would need to plug and chug. So is it fair to assume that you'd be able to do that? If you don't know how to solve equations by plugging in values from the graph into the equation itself, so you take points from here and you put them in here and you solve for k nag. If you don't know how to do that, okay, you're saying so yes, it's for sure you'd be able to do that. That's how you do it. But keep in mind, guys, that some basic math is required, and even if it's not required, just like everything else, it's about managing your time. If you can learn these shortcuts, why wouldn't you? It makes these patterns really apparent to you, and it buys you a lot of time that you can save for other more difficult problems. But yes, you'd be able to plug and chug. How would you be able to plug and chug? Well, I would use this point right here. You have to actually use a point. So the point is 0, 1. So if you plug in, so this becomes 1 equals 1 plus actually that's not going to help, is it? No. No, it's not going to help. Because it's going to cancel out this guy here. So we need a value that has nag in it. And perhaps this one? Yeah? I suppose you could use that one instead. 0.02, 2. So be 2 equals, yeah, you could do 0.02, 2. So then this over here would be 2 equals 1 plus, we're looking for this, times the nag, which is 0.02. And so now you can kind of see that you have 2 minus 1, which is 1 equals 0.02x. So again, we're left with dividing 1 over 0.02 equals x. So it's the same thing as here as over here. Okay. Fantastic. All right, so yeah, again, guys, once you're done practicing, what is the next step in the boogeyman method? Analyze. Okay? Please make sure that you analyze. Freshta has a question again about this problem. When we only found the slope and that was the answer, why did we just find the slope and not use the entire equation of a line? I'm not sure I understand your question, but what I will say, we disregarded the +1. The +1 is in the graph. So whenever you have an equation of a line, it's in the graph. So let me show you. It is right here. So that 1 over there is, Walter, can you tell us? 1 is b, and what is b? So you have y equals mx plus b. What does b refer to? The y-intercept. All right. Good job, Walter. Good job, Pyle. So, Freshte and Sandra, we did use the 1. You're welcome. Yeah. So no matter what you use, because so this graph over here is a visual or graphical representation of the equation of the line above. Freshta says, I get it, but how do we know that the value of k nag is exactly the slope? You wouldn't be able to tell purely from this equation alone. You would have to see the graph itself. So the graph is made up of a y-axis, an x-axis, a line, which is basically a bunch of points. And so the x-axis has the unit of nag, so we can safely assume that in y equals mx plus b, nag is x. This we already know is just a number, it's a y-intercept. This must be y, because over here. And so whatever's left is the slope. Yeah. It's a good question. Bianca says, would you go back to the question with the molar equation? Why did we choose the answer with nanomoles instead of micromoles? Good question. We chose the answer with nanomoles as opposed to this because the answer we got was 10 to the negative 7 moles. Correct? So what I did was I went and I used this answer, which I like to call answer choice E, and I compared it to the answers A, B, C, and D. This is never going to be right because it's 25. This is never going to be right. And so it was comparing between B and D. So I started with B, and I said we need to make these units equal. So I said, okay, 100 nanomoles is how many moles? So nanomoles, in scientific notation, how many moles are in 1 nanomole? Nano is 10 to the negative 9. Okay, so now we have equal units. The only thing left is the 100. So we have 100 of these 10 to the negative 9 moles. And 100 times 10 to the negative 9 is the same thing as 10 squared times 10 to the negative 9. And when you multiply bases that are the same, you just add their exponents. And so we do 2 plus negative 9, and that leads us to 10 to the negative 7 moles, which is the same answer we got up here. And Sandra says 1 times 10 to the negative 7 equals 100 times 10 to the negative 9. Just move the decimal over twice. Yeah, basically. Does that make sense, Bianca? Thank you. Okay, good. All right, guys. So good questions. I really, 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 really appreciate the engagement. That's the only reason why I do this. I just want to thank you for being here. For those of you who've been here, for all 8, 9 weeks of these study groups and study sessions. It's allowed me to really improve this process for you guys and get sharper and sharper with my explanations, which is something that I feel was missing when I was studying. I felt like the books and the solution manuals and the AMC provided very vague answers and didn't really answer all my skeptical questions, and you guys are all very skeptical people. So it's good. It's very indicative of an analytical mind, which is important to being a doctor or just taking the MCAT. And so by going through these sessions, we're all able to kind of grow and learn together and be better critical thinkers, better at interpreting data, better at strategizing, and most importantly, better at solving problems. Those 4 skills are going to be with you, not just in the MCAT, but as you go into medical school, become a doctor, go into business, life, relationships, every single aspect of your life, you will have problems. And by training yourself in this way, you'll realize, and you're going to look back at these moments that you're studying for the MCAT, and you're going to say, wow, I grew a ton. I don't care how old I am. I don't care how long it took me. I grew, and the old me was in the past. The new me is here, and the new me is confident. They are good enough for medical school. They've proved it for themselves, and they are now confident to be able to solve any problem in the future, learn any skill that they want, because now they have not only the skill of problem solving, but they have a tried and true method for studying and learning. Because again, learning is not something that happens overnight. It is a continual process, and it's very, very cyclical. So essentially, these tools, what you would do is you would then, we practice this passage, you then go over and analyze it for strategy. So you go to the bio-phys checklist and you ask yourself, did I read for understanding and not completion? Yes, we did. We read thoroughly. We didn't just skim and try to read for completion. Did I draw flowcharts for key relationships? No, there were no key relationships, so it doesn't matter. Did I pay attention to the question stem? Yes, we did, because, we know, first of all, the first thing we said over here, according to the passage, that's part of the question stem that we pulled out, made a note of. Did I use bracketing? I didn't explain it, but essentially most of these problems didn't require bracketing. They were very straightforward once you got to the right answer. When determining the strongest answer of the bracket, did I use MSLR? Again, wasn't really needed. They were all very straightforward. And did I come up with answer choice E, which is important to do in every problem? Answer choice E, if we relate it back to our problem-solving tree, which is you take a problem, you ask a question about it, and then each of those questions have answers. This collective set of answers from the questions that you ask from the problem that you're given, this is basically the solution to the problem, and I call that answer choice E. So you have A, B, C, D, and then your answer, which is E. So yes, we did do that for the whole passage. Great. So this checklist you would then do as part of your analysis. If you go through that checklist every single passage, you're going to get much, much, much more reinforcement for the strategies themselves. Right now, guys, the strategies for me are subconscious. They're habitual, so it's easy for me to apply them. For you guys, it might take much more practice, and a great way to practice it is by asking yourself these questions during your analysis, and that will make it stick a bit more. Once you're done analyzing for strategy, then you analyze for content. So you open up your spreadsheet, and then you make a note. Again, date analyzed would be 9, 10, 17. This would be physical sciences as opposed to the other sheets. Problem, I think it's section bank 6 or something. And then flashcard questions to add to Quizlet. So whatever questions you had, whatever questions you had, for example, convert, what is 100 nanomoles to moles? That's a flashcard question that you can ask. It's very specific, it's very focused, and it hits home with a concept that many of you struggled with. Bianca, specifically, you asked me that question, so that specific question goes into your flashcards. Another question was, what does the structure of alanine look like? Or I would say this, out of W, D, A and something else, which cannot hydrogen bond, right? So again, that question is directly from the passage. It's specific, it's focused, and it hits home to exactly a question that you guys may have made a mistake on. For Eshte, you know, you had a question about that. So those types of questions, they all go in here, okay? So then you take those questions, you open up Quizlet, you make one flashcard for one question. One question, one flashcard. And that would be the organization phase, okay? From there, you've organized all your flashcards from all your passages and all your practice. Then if you have previous flashcards that are kind of easier, delete them. And then you have all your flashcards ready to go, new and improved. Move on to the final stage, which is to drill them. What I would do is I would hit the, it's now called the write function, write on Quizlet. And you'll be able to go from there. And then move whenever you're done with drilling all of them and you get everything right at least one time, you move on to practicing more. And on you go over and over and over and over and over again. To go through one cycle takes sometimes 3 days, 4 days, 5 days per cycle. And by the time you spend, you know, months studying for the MCAT, you've gone through, you know, upwards, like between like 10 and, you know, even 50 cycles. And by that time, you're going to be very much a habitual problem solver. So hopefully this makes sense to you guys. Hopefully it was communicated effectively. This is the last free study session that I'm going to have. You know, from next week onwards, it's going to be a more structured masterclass. And so you guys can check out on my website. I'm still forming it out. I'll send you all an email whenever it's launched, the free ebook and the masterclass. But basically the way it's going to work is I really am retiring from one-on-one tutoring because I just found that I know I can find a way to help the most amount of people and still make it feel like it's one-on-one and personal. And it's something that I'm really, really pushing myself to get to because I know that you guys love having one-on-one time and you're afraid that it'll be, you know, not worth it for you. But if you just take a look at it, you'll realize that I've set up a 4-point accountability checklist. And the 4 points are right here. So I said, actually they're right, yeah, they're right here. It says, how will you keep me accountable? So this 4-point accountability system is we share a spreadsheet. I get to see what you're analyzing, and then I give you access to my Quizlet classroom. So I now paid for a Quizlet teacher version. So when I have Quizlet teacher, it allows me to see exactly how many flashcards you're getting right and wrong, and whether or not you're even doing them, period. So I know that's something that I desperately needed. And then I give you access to my Toggle workspace. So my full-time job, I'm a project manager for over 4 different startup companies, from a social networking app to data analytics software for businesses. And so project management and time management is something that I do on a day-to-day basis. And I made one separately for you guys, for my students, because I feel like that's, again, something that I would have, that based upon my discussions and conversations with you over the past 10, 11 months, that's been a huge, huge, huge issue. And then the 4th point of accountability is you get weekly reports with personalized solutions for the problems that you're facing based upon the spreadsheets, flashcards, and time management, as well as any questions you have for me. And the reason why accountability is massively important, if you guys remember from the very first lesson that we had here, I had that there were the two most important things for any successful MCAT student. When I went back and I really analyzed the patterns that made them common was that they all had a process to study. And with the Boogeyman method, you guys now all have a process to study. So that's there. And I'm making the ebook to make it even more clear on what to do. So that's the process. And the second thing that they all have is the motivation to commit to this process of studying day in and day out. And that's the only reason why I will ever ask for money, because it just takes time to keep people motivated and keep people accountable. And so if that's something that you guys require, I can help you. If not, then that's even better. So just remember those two things. You have a process to study for this thing, and if you don't have the motivation to commit, we are all here for you, and I'm here for you as well. So that's basically all you need to be successful for this massive undertaking, and proud of all you guys. Keep up the great work. You will hear from me via email soon. And any questions that you guys have, again, you will be able to contact me on my website, secondchancemcat.com, which looks like that. Or you can email me at nicholas@secondchancemcat.com. Every email starting from next week will include 3 things, and that would be a link to set up so it's going to include 4 things. It'll include a link to set up a free 30-minute phone call with me. It will include the ebook link. It will include an audio recording to accompany the ebook link, because I know that that's also helpful whenever you're reading something voluminous, to have an audio going on at the same time while you read. And also a link to this recording. So apart from that, just feedback is important. So anything that you guys need, again, keep communicating with me, and we'll make sure that we grow together and make this the most valuable resource for people who want to study for the MCAT. So if nothing else, that's all for now. So I will see you guys soon. Let me just stop recording.